Okay, so we are live with the next session. Welcome, everybody. So I'm delighted to introduce Vincent Hemery. Vincent, he's an Eclipse and modeling technical expert at CS Group. He is specialized in space modeling, which is super interesting, working for the CNES, which is a French space agency, and the European Space Agency. He still entertains general Eclipse modeling expertise to assist other projects and provide training. So, Vincent, I'll hand it over to you.
Thank you, Brian. Well, I'll tell you about our experience on the Disco project. We were trying to build a model application with Theia on EMF.cloud. So our agenda. First, we'll see about the context of the Disco project, then the features we needed for this project, and how we map them with technologies, a walkthrough of how to build such an application, and a recapitulative of all my tips. So the context. Disco is a modeler for editing satellite databases. It's a new framework built to replace BEST, the predecessor, which was old technology. It supports modeling and transformations of space databases. So the space database allow to present the sequence of bits which are exchanged between the ground and the satellite. We needed a new UI from this framework. It was built with EMF, and we needed better UI because the old UI is not sustainable. And we wanted this UI to be based on web technologies, since it's the state of the art. But also we needed offline capabilities. So we must have this desktop usage, which was one of our clients' requirements. Yep. So for the UI, we have to use the Disco core architecture. So the user needs an HMI, of course. This HMI relies on the Disco broker, which is part of the internal architecture, and it manipulates the model with EMF. So we also have a Java programmatic API exposed by the broker, which the user can use directly with Java library. And the broker can eventually delegate some heavy jobs to a domain server, which is hosted on machine with boosted capabilities. And we can also store the model in an EMF CDO persistent server, which allows to use the database storage instead of file for EMF. The Disco core frameworks, before the UI was developed, already manipulated big models. It stores its domain intelligence in profile definitions, which means we have dynamic meta models without generated classes. So the objects are created on the fly. It has faceted elements. Some of the properties are virtual, and they're not stored in the model directly for transformations. It supports multiple domains. It has multiple domain formats for live transformations, for import and exports between these formats. So Disco was also used as a model transformator, as a model transformation tool before the UI was developed. It also has XX expressions, but with textual elements which reference non-textual model elements. So it differs from the classic all resource in X-text usage. And we have some things that are quite customized on this. So it's not a small framework at all. It has complex problematics and a complex architecture. So why using Theia and EMF.cloud for this framework? It's all Eclipse technology. So we have a consistent ecosystem. We have compatible licenses, compatible technologies. As we're using already EMF and X-text, it makes sense to look for the cloud version. It has ELECTRON support, which fits with our offline use case. And it's not always obvious with web technologies to have offline support. It has workspace management. So we only had to bring a few adjustments to the Disco core framework to adapt from the Eclipse workspace to the Theia workspace. It's highly customizable, so we can rip off the parts we don't want, add whatever we need. So it was the obvious candidate for Disco UI. Why not using Serious Web? We already had some projects using the Serious desktop technology. But the Serious Web was released after we started the project, so it was a bit too late, even if we considered it. Moreover, it has non-EMF persistence, and this was a stopper for us because we wanted to rely on CDU persistence for big models, and it was one of the key points of the Disco architecture. Also, it shows the full model tree, which is too complex in Disco. This can probably be overcome, but anyway, hear me right. I'm convinced Serious Web is a great tool. It's not just the right tool for Disco. The features we needed. For most features we needed, we found a corresponding solution with Theia and EMF-cloud technologies. We needed a basic explorer to see our workspace. This is supported natively by Theia. Also, we wanted 3 views, including with columns. We looked at the THBA-TREE-EDITOR module. We are able to support columns with a few handmade customizations. We needed properties editor form. This is supported by JSON forms. And also we wanted in this form an expression editor with xtext. And the Monaco editor can be used to edit expressions with an LSP server, which can be implemented with xtext. So this was a perfect match for us. We also wanted to show validation reports, both the global validation results, but also each item individually, each entry. We use for this the Theia notification on one hand, and the problem view, which looked adequate. And also we wanted preferences per project, which are also managed by Theia. We refactored Disco to support Theia preferences instead of Eclipse ones. We also needed custom wizards and pop-ups, and that's the basic any UI framework can support. So we use Theia dialogues with React and Material UI components. Also, we need diagrams, boxes and the rows diagrams, but also more complex ones like the sequence diagram. There's a solution for that with EMF-cloud technologies for GLSP and Sprotty. We haven't developed it yet, but we already identified the solutions. And also we have something we call an encoding view, which is the sequence of bits seen as a timeline or as a grid. And we think GLSP and Sprotty can handle it, even if we've been looking for better candidates. So next, a short demo about what the Disco currently does. We start by creating a workspace and the projects in this workspace. We want Theia workspace organization to be separated in projects. We want something structured and what Theia allows. So we avoid confusion between workspace and project for the end user. So next we create a workspace. We have different modes for the workspace, for the project, sorry. We can then import a model in this workspace. So there we have test models which we can use. And this model is imported by the backend by Disco core. Once the model is imported, we can open it and edit it with a form view handled with JSON forms. We have several forms in there, not just one, but several forms integrated in our properties view. We also have custom actions to open overviews with more complicated contents. There we have a complex tree view with columns and a complex content provider. So we have a complex custom children logic. The elements you see in the tree are not the same as in the main tree view. We can also create new elements in the tree. So there I create an element which hosts an expression which we can edit with xtext. So this is a Monaco editor with LSP support, which delegates directly to the LSP server implemented with xtext. And there we have auto-completion, everything we need, including type validation performed with xtext and xsemantics. We also have a validate action, which launches model validation to the model server. So validation is performed by the backend with all the rules we specified in Disco. And then it creates markers, and each individual marker allows to navigate to the concerned element. There's also a search view. There we can look for elements in our model. This search view will display elements in a table. And in this table, we can also navigate to the concerned elements. So we have a quick access to the element, in addition to the container element column in the view. So a walkthrough of how we to build such a model application. First, you have to comprehend the Theia framework. So how do we start? There's documentation. The documentation may not be complete, but at least there's some. So we start by reading it, of course. And when developing with Theia, you have to respect the package convention, which will help you find things. I'll talk about that later, but backend goes in node package, frontend in browser, and when we want the interface between both, it goes in common. Then, once you've read the basic documentation, you can start playing with demonstrators. The Coffee editor is a very good starting point with lots of EMF.cloud features. And my first tip is when you want to explore a Git repository, such as the Coffee editor one, you can use Gitpod. You don't have to install anything on your computer. You just open the GitHub repository in GitHub, and voila, you have a full development environment. Gitpod used to open a Theia environment. Now it's based on VS Code, but it's still a very handy tool. And this will help you make prototypes or mockups by modifying the Coffee editor, for example. Now, the global Theia architecture, you have a Theia frontend and a backend, both implemented in TypeScript. They communicate through JSON RPC messages over WebSockets or REST APIs. And then you can use extra technologies with dedicated backends, and they connect to the backend of Theia. So examples are the LSP, the GLSP, the model server. You can have as many backends as you want. Whether these backends are deported or executed locally on the same machine, that's up to you. You have a lot of deployment configurations possible. For the servers, it's important to have a single source of truth, as explained in this YouTube conference, in this EclipseCon 2020 conference by Maximilian Kogel. You must not load the same information twice, nor edit it independently from different locations. So there's two ways to achieve this. Either you have interconnected servers and all servers consult the model from the EMF model server, or you can opt for one big server, which exposes other services on top of the EMF model server. So for Disco, we use the second options because we have a huge framework with a lot of services, and it's far easier for us. Technologies you should master for the backend server. Of course, Java, it's the language. Plugin development environment. You can have a look at Lars Vogel's tutorials on vogela.com. EMF, if you want to use EMF, of course, but also xtext if you want to use xtext, and any other technology you choose to use for these backends. You must masterize Google Juice, as it's used heavily by EMF-cloud model server. And for the Theia part, backend and frontend, it's implemented in TypeScript. You should be able to use React if you want to use the React library, especially with hooks. If you use Material UI, it's just a React library, so the same principles apply. Inversify is used for dependency injection. And the Theia events allow you to dispatch notifications. You may also be interested in the asynchronous versions. The synchronous version is well documented. For the asynchronous one, you should look at examples for understanding how to use them. You must be able to navigate in complex frameworks. All these technologies, Theia, EMF-cloud model server, XX, Inversify, React Material, they are not always intuitive, and you may have to muddle your way through the code sometimes. If you're building a new team, I suggest you foster on profiles with general experience, whether on a specialized front-end profile. We had developers with back-end experience, they have a full stack experience, and they had less difficulties adopting Theia than unexperienced front-end developers. Then, if you want to move to Electron, just like we did, you have to learn about Electron Builder. And you can look at Theia Electron as an example. So it tells you how to build a Theia application on Electron. You can then easily adapt the Coffee editor, which you started from, to launch it with Electron. For the development environment, Theia uses native node modules. So if you use Electron, you have to recompile these on the same OS as you want your application to run on. So you can build the Windows product on Linux. You have to use Visual Studio C++ build tools if you want to build these on Windows. So in the end, whether you use Windows build tools or directly Visual Studio, it will download Visual Studio C++ build tools. So you have to look at the license. You may find on some websites that the community license of Visual Studio is free. That's the case only for open source projects, which was our case, luckily. But if you want to build a proprietary application on Windows, you have to pay a Visual Studio license, or this will make you a pirate. On a great article by Jonas that I suggest you take a look at, Jonas tells us that EMF-cloud model server is not a new persistence, and you can use any existing persistence you want, including EMF resources. That's true, but when you look at the code, you'll see that the default model resource manager works with a URI. If this URI isn't a file URI, then it creates a file URI instead. So this means that the default implementation does not support CDO URIs, for example. And if you want to have custom protocol support, then it won't come free. You have to implement some things to override the default implementation. So if you want to plug the model server on top of your application, you have to start your framework first, then launch the model server. You start the model server launcher, you configure it, you give it the injectors you want, configure a few aspects, then you actually launch the model server. Everything else you need to configure, you can do it in the model server module, which is Disco server module for us. And you do it with juice bindings. Especially if you want to have a custom resource manager, this will be very useful to provide a binding for a new one. You may want to do so because of a URI protocol limitation we saw earlier, but also because the default implementation currently loads all models, where there may be another implementation coming in the future days, but for the moment, this can be critical for big models. Also, you may want to customize editing domain or resource set, just like we did. The current model server implementation doesn't work with standard interfaces, but with custom classes. But you can override them and use extend to delegate to your own implementation. So I suggest you use extend for your backend, because this will help you a lot for fast development. extend is better, is Java-like, but with a few enhancements. You may have to do some refactoring later when you update, but this is really for the greater good because the technology evolves very fast, but on the other hand, things becomes easier to use. And most times when you update to more recent EMF-cloud model versions, you will have old code which was here as workarounds, which are no longer necessary. So this will make your code cleaner and easier to maintain. You also probably want to override the codecs. There's a pull request I made which make it now easy. If you use custom codecs, you can add the lazy loading. In the JSON encoding, we use a custom compiler in which we replace containment references we don't want by proxies. So this way you can control the granularity of objects you transmit to the Theia framework. For model, we add data and sub-elements, and we didn't transmit the children data, but only sub-elements attached to the same data. So we have a granularity organized in the Disco model, and this is the granularity we choose to transmit with EMF model server. You can also migrate IDs which are XPath by default to XMI or CDO IDs. So for the decoding, it's already done because it relies on your resource. For the coding, in this compiler we just report the IDs from our backend resource to the JSON transmitted resource. We also needed extra services. So what we did here is we separated things to keep a clean architecture. So there's the default model server implementation. We override it with our model server custom implementation. And this module only does customizations of the model server aspects. And then we have another module which provides new bindings, new endpoints with water binding. And with this routing binding, we add new endpoints, and this is where we implement our new services and some things which are not related directly to the model server. So next, the question which comes is when do we want a new service, a new custom service, or a new command? The question you have to ask is, do I modify the model? In case you modify the model, I suggest you do not use a custom service, but instead that you use a custom C command, which you can implement with a model server. The question is, which is the granularity of your operation, which is the atomicity of the operation? If you want the undo and redo to work correctly, the command, you have to think about the atomicity of your operation to wrap it in a single command. So how to use custom commands? The custom commands are now easy after the modifications that Martin Fleck from Eclipse Source has done to the model server. So you just have to bind a new configure command codecs. In configure command codecs method, you just have to bind a new codec. And in this codec, you implement the toServer method. And then you can transform your command to the backend command. I suggest you use for the backend EMF command, you use a custom command extending the recording command. This will work with transactional editing domain, and this will avoid you to have to implement undo and redo behavior. This will be all undone by default. On the front end, when you create a command, you have to set an owner for this command, or the serialization will fail on the server. In case you want advanced command with complex attributes, you can do so by defining a new eCore command meta model. In this meta model, you inherit the command eClass from the command eCore model in the model server framework. And I suggest you use the e-class name as a contribution key for your binding of the codec. You have to copy e-class knowledge to Theia plugins, so you can create commands, your custom commands, from the Theia side. Then you can extend model server command, and you can then go from the front end to the back end and have the full command execution. So using the Theia-TREE-EDITOR, so we inspired from the resource TREE-EDITOR widget, and then we diverged from it. So at first we used it directly, then we started removing things, and in the end we did a complete fork of this class. We did our own implementation, but it's good to look at this one at first. We customized it, we added columns, we overrided we added overridable node factories, so we can bind new factories in our views. And we also added lazy loading, so we can have lazy EMF, lazy tree loading, and load only the elements we see on the screen with the model server. We also added an index, which allows us to find elements in the tree to have quick navigation directly from elements such as the search view of program reports. Now what I call the synchronous nightmare. It occurs when you must implement a synchronous method, in which you want to get asynchronous content to return it. So the easiest way is most probably to change the interface to have maybe promise from Theia, which can work with both synchronous and asynchronous implementations. It makes sense. When it makes sense to change the interface, you can do so on EMF.cloud because it's still young enough. On the other hand, if you can't change the interface, if you use Theia core methods which are already well established, you can work around the problem and find somewhere in the code where you have an asynchronous call, store the result temporarily, and then return it synchronously. The model batch validation was introduced by Simon Quadrant, and it came in the model server API while we were needing it. So that was a perfect timing. And when we take the diagnosis reported by the model server validation, we log them in the problems view. This is something we have contributed in a model server macros Theia module. So now you can use it too. And this is something that is now available publicly. Also, there's a concept of live validation in the model server. This is not the same as EMF live validation. This does a full model validation whenever you modify a single aspect on the model. So I suggest you disable it for big models because it can be critical for performances. On the other hand, we wanted model live validation, the EMF live validation. It makes command fails, so by default, the command just fails on the model server. And we caught this failure to collect the error status, and we hijacked the live validation event to broadcast our event and return an accepted 202 status instead of the 200 status. So we use a special transitory command. There's a use case for this, in which we have a command which always fails, which we use to validate without steps. So we perform the validation of modifications in this command to ensure the without step is correct, but we cancel the command not to modify the model before the full wizard is completed. Now the refresh versus edit race condition. We had the problems. We had the race condition. Here's the coffee editor. When you type 1, 2, 3, 1 to 10, you have 3 digits missing. So here's what happens actually. You start typing text, you type text again. The events are batch, which is okay. Then modifications are sent to the model server. The model server updates the model and then send a notification to Theia to refresh the UI. And in case you are typing quite fast, then you can have a conflict here because you start sending over modifications before the refresh occurs, and you can have conflicting refresh and modifications. It can get much worse. This is in an early prototype we had. Since our model server is slower than the default implementation, when we start typing ABC, it loops between A and AB states and never reaches the ABC state. So we did overcome this. We solved it using deferred from Theia and Mutex. And basically what we did was adding a command ID to the command we send and delay any new update before the corresponding refresh happen. And when there isn't a refresh, we handle it as an error. So there is the final UI. We can fluently type the whole alphabet, and there's no problem, and everything works just fine. So recapitulative of my tips. First tip, use Gitpod. Gitpod is great to explore repository quickly, and you can also run examples directly in it. Look at Lars Fogel's tutorial for the PDE stuff. These are great tutorials. Foster on profiles with general experience, whether from an unexperienced front-end developers. Beware, the Visual Studio license can be very tricky, so if you're using it, look at your license, your product license, whether it's compatible or not. Also, use extend in the backend implementation. You can use the delegate annotation, which is quite handy. Be prepared for slight refactoring. You will have to perform some refactoring when you upgrade the version. Use CCOMMANDS. They are very, very handy. And for CCOMMANDS, I suggest you extend recording command for the backend command. I suggest that you use the class name as juice key for binding, and you will have to set an owner on the front-end command. Extra tips. When Theia won't start, look for DI wars in the console. You have Theia developer tools, and there you can see the console in ELECTRON. And usually it's the DI dependency injection errors. When you do update some dependencies, it can be complicated to handle it only with a yarn lock file. So inspect yarn lock for when it's changed, and use selective version resolution. This will make your dependency management much easier, specifying the dependency versions directly in the POM, in the JSON, in the manifest. Extra tips, you can use the JSON forms edit. This is a web application which is very handy for JSON forms. And watch for new repositories. An example is the properties view, which was introduced recently, which we didn't use because we already had our own properties view quite advanced, but can be very handy for when you're starting. For EMF.cloud, you can still change the API. It's not too late, so do so when it's appropriate. Participate. There are many ways to participate, as Jonas told us earlier. You can ask questions, make suggestions, create documentation, tutorials, submit pull requests. If you don't have all the competencies to submit pull requests, it's not a blocker. You can participate at many levels. So join the community. We need more adopters, more contributors. Eclipse Source does an amazing job at animating the community, but it's important to have also companies engaging in this community to have something sustainable. And why didn't we contribute all this to EMF.cloud? Because some are too customized, too dedicated to our own tool. And mainly when we could and haven't contributed, this is because we lacked the time, because we had a tight budget and our priority was to make something stable for our clients. Special thanks to people at EMF at Eclipse Source who reviewed my contributions and suggestions. So Martin Flake, Nina Toshek, and Lucas Kohler. And of course, thank you for your attention. Ask me your questions and participate to EMF.cloud. Don't hesitate to join us on this EMF.cloud contact. So questions, there's not a lot of them. Is the workspace concept for Theia workspace, but with non-file URIs or something completely different? The workspace is the Theia workspace. We used it and we refactored this code to use the Theia workspace. For non-file URIs, we haven't implemented yet, but what we want to do is to have CDO projects hosted on CDO. So we just want to have pointers in the workspace file and point to these distant projects. So we will have to do some refactorings and contributions in the Explorer view, but that's something we can overcome, I think. Are there other questions?
Vincent, Brian here. A question: Can you kind of give an idea of your user base from a kind of a non-technical viewpoint? Like, how is your tool being used day to day? Is it something you can disclose?
Yes, of course.
And maybe as part of the answer, talk about their reaction to it so far, you know, in terms of scalability and stability and so on.
Yes, we have big models. So there were some models which were up to a few gigabytes, but these models had a lot of redundancy, so we managed to scale them back to over 100 megabytes. But we have big models, so that's the reason why we didn't want to have file persistence to start with, but we started this core project only with a core, not with a UI. This was a separate call for offer. So the UI came after the core framework, and the core framework relied on CDO for these reasons. Our users are people who develop the satellite databases. So they want to modelize exchange between the ground and the satellite database. This comes early in the conception of the satellite. So this is to conceptualize the message is exchanged. So there are people at CNES mainly. So we developed this product for the CNES, the French Space Agency. We may have other future clients like ESA, or maybe extend the tool in the non-space domain, but it's not a current preoccupation. So for the moment, we are mainly focused on the CNES, which is our client for this product.
Okay, thanks.
So
and, one more question came in there. It's inquiring whether Extend is a tool that may be discontinued. Yeah. In your experience, what you use in your project based in Extend cannot be implemented in pure Java or any other option?
I haven't heard about the Extend discontinuation, but maybe I just haven't heard about it. In any way, it's not a problem if it's discontinued for the existing code, because Extend does compile in Java code. So when we use Extend, we have Java classes generated automatically. So if we no longer have Extend support, we can just use the generated Java classes, and they're not pretty code, but at least it can still work. And well, if you don't want to use Extend, I think maybe the reason for discontinuation was the recent improvement in Java, because Extend was much better from Java in earlier Java versions, but the more Java gets updates, the more it level ups with Extend. So maybe you won't need Extend if you use the latest Java, but for the moment, we are still using Java 11. We started with Java 8, we upgraded to Java 11, so maybe in the future, we won't be needing Extend any longer.
Great, fantastic. Thank you, Vincent. That concludes the session. So
Thank you.
again, another great use case for Eclipse Theia, and thank you for all your work.